Hi everyone, I am Mrs. P. Muthumari, working as an assistant professor, Department of ECE, Kamaraj College of Engineering and Technology, Virudhunagar. I hope you all enjoyed by watching my previous videos. In this video, I am going to discuss about star-delta transformation. Why we go for star-delta transformation? The basic connection between the resistances series as well as parallel. We fails in series in parallel, we can go for star-delta. We can take small example. This is star network. So basically star as well as delta has three terminals named as A, B, C. So this resistance named as RA, B terminal resistance named as RB as well as RC. This is a star network. In this star we can replace delta network by connecting the terminals. By connecting the terminals we can get the delta network. By connecting A and B we can get the resistance named as RAB. This is the delta network RAB. By connecting B and C we can get the delta resistance RBC. By connecting A and C we can get the delta network, the delta resistance RCA. How we can find RAB, RBC and RCA? By using this small formula. Okay, now we can find the delta resistances RAB, BC and RCA. Okay. For RAB, the shortcut formula here is circle divided by opposite resistance. What do you mean by circle here is the star resistances multiplied by this routine. RA multiplied by RB, RB multiplied by RC and then RC multiplied by RA. RA into RB, RB into RC plus RC into RA. This circle divided by the opposite resistance. The opposite resistance for RAB is RC. So the opposite resistance here is RC. Then we can find RBC. So for RBC the same circle repeated here. The numerator is same for 3 delta resistances. So the same numerator will be applicable here also. The opposite resistance for RBC here is RA. So the denominator only varied, this is RA. Then we can find RCA. So in this RCA also numerator is same. The same circle will be repeated here also. The opposite resistance for RCA is RB here. So this is the formula. By using this formula we can find the delta resistances. For example, we can take this circuit. So in this circuit RA, RB and RC is given star values. RA equal to 3 ohm, RB equal to 4 ohm and then RC equal to 5 ohm. This is the given star values. We can identify the delta values. So first delta value here is RAB. Now we can find RAB. The formula already we known as circle divided by opposite resistance. So we have to find the circle here is 3 into 4. So formula already known RA into RB plus RB into RC plus RC into RA. So 3 into 4 plus 4 into 5 plus 5 into 3. This reflects the circle divided by the opposite resistance for RAB here is 5 ohm. So this circle value you can find divided by 5 ohm. So 47 divided by 5 which is 9.4 ohm. So RAB is 9.4 ohm. By using the same way we can find RB as well as RCA. So RBC, for RBC we can use the same circle here. So the 47 numerator value is same for RBC as well as RCA. So 47 will be common. Then the opposite resistance for RBC is 3 ohm. So 47 divided by 3 which will gives the result as 15.66. And then the third delta resistance here is RCA. For RCA numerator amount is circle 47 same. The opposite resistance for RCA here is RB, the value is 4 ohm. So the 47 divided by 4 which gives the result as 11.6 ohm. So the given star values here is 3 ohm, 4 ohm, 5 ohm. We can get the delta resistances values are 9.4, 15.6 and then 11.6. So we can conclude or verify the delta resistance here is the given star values are smaller amount, we can get the larger amount than star amount here. So, given values 3, 4, 5, we can get the maximum amount of 3, 4, 5 here is 9.4, 15.66 and then 11.6. Now, we can see how convert delta network into a star network. The delta resistances are named as RAB, RBC and then RCA. We can find the star resistances are named as RA, RB as well as RC. How we can find the star resistances? By using delta resistances. Okay. How we can find the star resistances? So, we can find the star resistance by using the smallest and simplest formula here is adjacent sides divided by total resistances. The given delta amounts are added by getting this total. For star resistance RA, RAB and RCA comes under adjacent sides. For the star resistance RB, RAB as well as RBC adjacent sides for RB, and then for RC, RCA and BC will be the adjacent sides. So, first RA, the adjacent sides here is RAB as well as RCA. So, RAB multiplied by RCA, this is the numerator for finding RA, divided by the total resistances here is RAB plus RBC plus RCA. The given delta amounts will be added. So, RAB plus RBC plus RCA, this will be the total resistance. The adjacent sides for RA is RAB and RCA. By using the same rule, we can find RB. The adjacent sides for RB is RAB as well as RBC. So, RAB and RBC values will be multiplied as a numerator and denominator will be the same for RA. So, RAB plus RBC plus RC, this will be the total for RB also. How we can find RC? So, the adjacent sides for RC here is RBC and RCA. So, RBC and RCA are the adjacent sides for RC, and then total resistance is same, it is RAB plus RBC and then RCA. This is the general formula for finding star resistances for the given delta resistances. Okay, for example, you can take this circuit. So, for RAB is 10 ohm, RBC is 20 ohm and then RCA is 30 ohm. Let us take this example. So, we can find RA first. For RA, the adjacent sides is 10 ohm as well as 30 ohm. So, in this formula, you can find RA 10 into 30 will be the numerator, divided by the total will be 10 plus 20 plus 30. The given delta amount is 10 plus 20 plus 30. So, it will reflect 300 divided by 60. It will gives 5 ohm. For given delta resistances, we identified the star resistance RA is 5 ohm here. By using the same principle, we can find RB as well as RC also. For RB, the adjacent sides for RB is 10 ohm as well as 20 ohm. So, 10 multiplied by 20 divided by the same total values we can take on 60. So, 200 divided by 60, this will be resultant 3.33 ohm. So, RB is 3.33 ohm. Next, we can find RC. So, the adjacent sides for RC here is 20 as well as 30. So, 20 ohm multiplied by 30 ohm divided by the same total we can take. So, 600 divided by 60, which will gives 10 ohm. So, the given delta amounts are 10 ohm, 20 ohm and 30 ohm. The resultant star values are 5 ohm, 3.3 ohm and 10 ohm. In my previous statement, the star values are smaller, always star values are smaller, delta values are larger. So, in this example also we can verify this. So, given delta amounts are 10 ohm, 20 ohm, 30 ohm, we can get the star values are 5 ohm, 3.33 as well as 10 ohm. So, these are the smaller amount when compared to 10 ohm, 20 ohm, 30 ohm. Okay, we can take this problem as a second example. In this example, we can assume the same values of delta resistances. So, the delta resistances here given. So, 30 ohm, 30 ohm, 30 ohm. The same amount of resistances taken as a delta resistance. What value will get the star values we can calculate. RA, the adjacent sides for RA here is 30 as well as 30. So, the adjacent sides 30 into 30 divided by total here is 30 plus 30 plus 30, it will reflect 90. So, 900 by 90 will gives 10. In the same way, RB, RAB as well as RBC. For RB, this 30 and 30 will comes under numerator. So, the same amount of 900 by 90 will give. So, the 10 ohm give the result as RB also. Next, we can find RC. In this RC also, the adjacent sides is same amount. So, the same 900 divided by 90 which will gives 10 ohm. So, in this we can conclude the same amount of delta resistances will give the same amount of star, but how we can verify this amount or how we can easily identify this amount is this delta amount divided by 3 exactly. This 30 divided by 3 will give 10. So, delta resistances divided by 3 will give the star. This is the state formula for finding star resistances. We can find the star by using same amount of delta resistance, means the same delta resistance divided by 3 will give the result as star resistances. By using this principle, we can find the delta resistance also by using same amount of star resistances. So, in this example, we can assume this 30 will comes under star, means it will give the delta resistances will gives 90. So, this formula will be converted into delta resistance equal to 3 into star. The star resistances multiplied by 3 means we can get the delta resistances. So, for example, 30, 30, 30. This is a given star value, means we can get the delta amount, means this 30 will give the result as 90 ohm as a delta resistances. To conclude, if all the resistances are same in a star to delta network, how we can find the delta network here is delta equal to 3 into star amount. So, for example, the star amount given the same value here is 20 ohm, 20 ohm and 20 ohm. This star amount multiplied by 3, we can get the delta amount is 60. So, same amount of 60 will be the 3 delta amounts for this network. By using same principle, if all the resistance are same in delta to star network, how we can identify the star means, so star equal to the delta amount divided by 3. So, in this example, delta amounts are 30, 30, 30. We can get the star amount is this 30 divided by 3. So, the resultant amount is 10 ohm will be the star resistances. Okay, thank you.